Generations have gazed up at Betelgeuse, the enormous red supergiant star that dominates the shoulder of the Orion constellation, with awe and wonder. Now, a shocking claim from Elon Musk has cast a new light on this celestial titan. Musk asserts that Betelgeuse, one of the largest and brightest stars visible from Earth, is just 2 weeks away from exploding in a supernova. This statement is not only dramatic but has ignited widespread concern, especially due to Musk's added warning. The effects of such a colossal cosmic event could directly reach Earth, particularly impacting specific regions in the northeastern United States, including New York, Connecticut, and New Jersey. The very idea of Betelgeuse going supernova isn't entirely new. In fact, scientists have speculated about its eventual fate for decades, noting the star's erratic and frequently puzzling behavior. However, what has truly caught everyone off guard is Musk's precise and alarmingly short timeline. While it is widely acknowledged among astrophysicists that Betelgeuse is nearing the end of its life cycle, no reputable scientist has ever dared to suggest a definitive countdown, until now. This deviation from the norm has caused many to pause and wonder whether Musk, known for his bold and often unconventional insights, might possess information or data not yet available to the public or even to parts of the scientific community. To fully understand the gravity of Musk's claim, one must appreciate what Betelgeuse represents in astronomical terms. Located in the Orion constellation, Betelgeuse is a red supergiant approximately 640 light-years from Earth. Its size is mind-boggling. If placed at the center of our solar system, Betelgeuse would extend beyond the orbits of Mercury, Venus, Earth, and even Mars. It is about 700 times the size of our Sun, and it shines so brilliantly that it can be easily spotted with the naked eye, particularly during the winter months in the northern hemisphere. Despite its serene and gentle reddish glow, Betelgeuse is anything but stable. Over the past few decades, scientists have carefully monitored the star's behavior. It has shown several signs of instability, most notably in the form of significant fluctuations in brightness. One particularly memorable episode occurred between late 2019 and early 2020, when Betelgeuse experienced a dramatic and noticeable dimming. The phenomenon was so pronounced that even casual stargazers took notice, sparking widespread speculation that the star might be on the verge of going supernova. Yet after several months, Betelgeuse began to brighten again. Scientists later concluded that the dimming was most likely the result of a combination of internal stellar processes and the formation of dust clouds in the star's outer layers. Still, the incident left lingering doubts and questions. Was this merely a false alarm, or a sign that the end is indeed near? Predicting a supernova is among the most challenging tasks in astronomy. Stars like Betelgeuse can live for millions of years, and though they may exhibit symptoms of aging or instability, determining the precise moment of their collapse is nearly impossible with the tools currently available. This is why Musk's recent claim is so provocative and unusual. A 2-week timeline implies either the emergence of new, highly sensitive data or access to undisclosed insights that could fundamentally change how we understand stellar death. Interestingly, while Musk's statement has caused a stir, some within the scientific community have echoed elements of his concerns, albeit with significantly more caution. Theoretical physicist Michio Kaku, for example, has spoken publicly about Betelgeuse's condition. He acknowledges that the star is likely nearing a supernova event. However, Kaku stops short of endorsing Musk's specific timeline or his warnings regarding the potential consequences for Earth. He contends that while a supernova could indeed happen soon on an astronomical timescale, which could mean in the next 1,000 or even million years, it is highly unlikely to pose an immediate, direct threat to life on our planet. So, what exactly happens when a star like Betelgeuse explodes? The result is both spectacular and violent. A supernova signifies the catastrophic end of a massive star's life. When such a star exhausts its nuclear fuel, it can no longer support itself against the immense force of gravity. This imbalance causes the core to collapse, followed by a massive explosion that sends powerful shock waves and radiation throughout the cosmos. For a brief moment, the light from a supernova can outshine an entire galaxy. In the case of Betelgeuse, this explosion could make the star so bright that it would be visible in broad daylight and capable of casting shadows at night, a celestial event unlike anything modern humanity has ever witnessed. However, Musk's concerns are not focused on the spectacular visuals. Instead, he emphasizes the potential radiation fallout from such an explosion. He warns that the supernova could unleash powerful gamma rays and cosmic rays, both forms of high-energy radiation that might impact Earth's atmosphere and technological infrastructure. According to Musk, regions such as New York, Connecticut, and New Jersey could face various disturbances, including satellite malfunctions and even disruptions to the electrical grid. Gamma rays, in particular, are of concern due to their ability to strip electrons from atoms, which can damage electronic systems and interfere with vital communication satellites. These high-energy waves are also capable of altering the chemical composition of Earth's upper atmosphere, potentially leading to ozone layer depletion. Cosmic rays, charged particles traveling at near-light speeds, pose their own set of dangers, particularly to satellites and high-altitude aircraft. Although Earth's magnetic field and thick atmosphere provide considerable protection, an especially intense burst from a supernova could temporarily overwhelm these defenses. Still, it's critical to put all of this into perspective. Despite its enormous size and potential energy, Betelgeuse is located approximately 640 light-years away from us. While this is relatively close in cosmic terms, it is still far enough to provide a natural buffer against most dangerous radiation. Most experts agree that while a supernova would be an awe-inspiring sight from Earth, it likely wouldn't cause catastrophic damage here. The vast majority of gamma rays and cosmic rays would weaken significantly over that distance and dissipate long before they could reach Earth's surface. That said, potential vulnerabilities remain. Our modern civilization is heavily reliant on technology, particularly satellites and digital communication systems, which are highly sensitive to radiation interference. GPS systems, communication networks, and weather monitoring tools all depend on satellites. A strong enough burst of cosmic radiation, even if it doesn't pose a threat to human life, could still result in temporary malfunctions, signal disruptions, or even complete blackouts in certain systems. In this context, Musk's warning, while alarming, touches on genuine concerns about the fragility of our global infrastructure. Beyond the technological implications, there are also biological concerns to consider. Cosmic radiation, though largely blocked by the Earth's atmosphere, can still pose a health risk to people who spend long durations at high altitudes, such as airline pilots and astronauts. While exposure on the ground remains minimal, those flying at cruising altitudes could experience a measurable increase in radiation levels. While unlikely to cause immediate health problems, prolonged exposure could contribute to long-term issues like increased cancer risk or other complications associated with radiation exposure. In spite of these concerns, most astrophysicists maintain a cautiously optimistic outlook. They believe that Betelgeuse's eventual supernova, whenever it may happen, will serve not as a disaster but as a once-in-a-lifetime scientific opportunity. For astronomers, observing a supernova in real time represents the ultimate cosmic event. It would enable the collection of critical data on stellar evolution, the creation of heavy elements, and the fundamental processes that shape galaxies. Every telescope on Earth and in orbit would turn toward the explosion, capturing images, spectra, and radiation data with the hope of unlocking new cosmic secrets. The excitement surrounding such a rare event isn't limited to academic curiosity. Supernovae are essential to the formation of life as we know it. The very elements that make up our bodies and our planet, carbon, oxygen, iron, and more, were forged in the nuclear furnaces of exploding stars. Witnessing Betelgeuse's explosive end could deepen our understanding of how our solar system, and perhaps life itself, came into being. It would also help refine models used by scientists to predict the behavior of other massive stars and anticipate similar events in the future. As the days go by, the eyes of astronomers, space agencies, and stargazers remain fixed on Betelgeuse. Elon Musk's audacious prediction has certainly added a sense of urgency to ongoing monitoring efforts. Even if his timeline turns out to be inaccurate, it has sparked renewed global interest in one of the universe's most mesmerizing phenomena. Whether Betelgeuse explodes in 2 weeks, 2 decades, or 2 millennia, one thing is undeniable. This massive red giant is in transition, and its final act, whenever it comes, will be an event of immense historical and scientific significance. In the meantime, astronomers are not sitting idly by. They continue to gather and analyze data, comparing information from both space-based observatories and ground-based telescopes. They examine spectral signatures, monitor changes in brightness, and study infrared emissions, all in search of clues that might signal an imminent collapse. Even if Musk's exact forecast doesn't materialize within the stated 2-week window, his statement has reinvigorated the scientific community and captivated the public imagination. The possibility of witnessing a supernova with the naked eye, a luminous burst that could remain visible in the sky for months, is more than just an astronomical curiosity. It is a profound reminder of the ever-changing nature of our universe. It demonstrates that even the most ancient and distant celestial bodies continue to harbor mysteries that challenge our understanding, provoke our curiosity, and, at times, stir a little fear. Whether or not Betelgeuse explodes in our lifetime, This moment serves as an invitation to look upward, contemplate our place in the vast cosmos, and appreciate the dynamic and unpredictable universe we inhabit. As we continue to gaze toward Betelgeuse, a larger reflection emerges, not just about the science of stars, but about how humanity reacts to cosmic uncertainty. Elon Musk's bold prediction, while speculative, illustrates a growing trend in how figures with high visibility and access to technology can influence global attention. Musk has repeatedly demonstrated an ability to shape narratives around science and space, whether through SpaceX's Mars ambitions, Neuralink's AI integration, or Tesla's futuristic visions. His pronouncement about Betelgeuse may very well be a continuation of this pattern, using shock and intrigue to ignite widespread curiosity and, perhaps, prepare society for cosmic phenomena that were previously confined to scientific journals and observatories. While scientists caution against assuming such an exact timeline for supernova, they have also acknowledged that Betelgeuse is certainly on the brink in stellar terms. What that brink means is up for interpretation. In the life of a star, soon might mean thousands of years. Yet, there is something deeply unsettling, and at the same time captivating, about the thought that a cosmic event of such magnitude could occur not in a distant future, but in the time it takes a paycheck to clear, a package to ship, or a vacation to end. Musk's 2-week window may not be supported by peer-reviewed research, but it has achieved something arguably more powerful: it has made people look up. The fascination with celestial explosions is not new. Ancient civilizations often viewed bright stars and sudden appearances in the night sky, what we now know as novae and supernovae, as omens from the gods. In Chinese astronomical records, several guest stars were documented with incredible precision. One of the most famous was the supernova of 1054 AD, which was recorded by Chinese and Arab astronomers and later identified as the origin of the Crab Nebula. Indigenous cultures across the Americas and Australia also passed down stories of sudden stars that burned like the sun before fading into history. Could Betelgeuse be the next star to be inscribed into global lore? If Betelgeuse does explode in our lifetime, it will be the most observed and recorded supernova event in human history. With global networks of telescopes, both amateur and professional, smartphone cameras, social media, and artificial intelligence capable of analyzing light curves in real time, we would capture the event from every angle, across the full electromagnetic spectrum. Infrared, ultraviolet, X-ray, and gamma-ray telescopes would provide layers of data never before possible. Whereas previous civilizations interpreted such phenomena through myths, we now have the tools to dissect them with unparalleled clarity. Still, one cannot entirely separate the awe of a supernova from its emotional and philosophical impact. There is something profoundly humbling about watching a star die. Stars like Betelgeuse spend millions of years forging elements deep in their cores. Over time, through fusion, they create heavier and heavier atoms: carbon, oxygen, silicon, and eventually iron. But fusion ends with iron. The star can no longer generate the pressure needed to resist gravitational collapse. In that final instant, a shockwave blasts outward, ripping apart the star and scattering its enriched elements into space. What remains might be a neutron star or a black hole, objects so extreme they defy conventional understanding. This process, though violent, is also creative. Every atom of iron in your blood, every bit of calcium in your bones, every gold ring and silver coin, all were made in the hearts of stars. When Betelgeuse explodes, it will be enacting a cosmic ritual of death and rebirth that has shaped galaxies for billions of years. In a very real sense, we are stardust witnessing its own origin. That realization, bridging science and poetry, is what makes this moment so profound. In practical terms, what are agencies doing to prepare for such an event, even if it's not imminent? NASA, the European Space Agency, ESA, and other global institutions already have contingency protocols for monitoring and reacting to high-energy cosmic events. The Fermi Gamma Ray Space Telescope and the Hubble Space Telescope are constantly collecting data that could be relevant in the case of a supernova. In addition, next-generation observatories like the Vera C. Rubin Observatory in Chile and the James Webb Space Telescope are poised to offer unprecedented detail if and when the explosion occurs. Ground-based detectors such as neutrino observatories, like Kamiokande in Japan or IceCube in Antarctica, could pick up the ghostly particles that are expected to arrive before the light of the explosion reaches Earth, giving us an early warning system of sorts. Neutrinos, in particular, are key. These nearly massless particles are produced in enormous numbers during a supernova. Unlike photons, which can take hours or even days to escape the collapsing star, neutrinos travel unimpeded and would arrive at Earth first. Detecting a burst of supernova neutrinos would give scientists an invaluable head start to prepare instruments and confirm the impending arrival of visible light. This early warning capability, while still in its infancy, represents one of the many ways humanity is becoming more attuned to the rhythms of the cosmos. And what about cultural readiness? How might the general public respond to a blinding new sun in the sky that doesn't rise or set like the real one, that stays visible at night, and that glows with a brightness never before experienced? Governments and media organizations would be tasked with immediate education campaigns to prevent panic. Imagine if Betelgeuse exploded without warning. Headlines would scream, conspiracy theories would run wild, and religious interpretations would flourish. People might mistake the bright object for a UFO, a nuclear detonation, or a biblical prophecy. Schools and universities would shift curricula to explain what was happening, observatories would stream live coverage, and perhaps most powerfully, billions of